Hello and welcome back to Tech and EduSpark Hub, where technology meets education. In today's lesson, we'll be looking at friction, and under this, we'll be looking at the definition of friction, types of frictions, the laws of frictions, and how to calculate frictional force. And lastly, we'll be looking at real-life examples and MCQ questions under friction. Firstly, what do we understand by friction? Friction on a layman term is a force that opposes motion, but we can define friction as a force which acts at the surface of separation between two objects in contact, and it tends to oppose the motion of one over the other. And we have two basic types of friction. The first one is the static or limiting friction, and the second one is the kinetic or dynamic friction. And by definition, we have the static or limiting friction as the maximum force that must be overcome before a body can just start to move over another. So what does this mean? This means that the static friction or the limiting friction is a force that must be overcome when a body, okay, let's say for example, a body is in a state of rest. So before the body starts to move, there is a frictional force that is limiting the body in that position of rest. And before the body starts to move, there is a static or limiting friction that is limiting the body in that position. So the maximum force that must be overcome in that state of rest before the body starts to move over another is known as the static or the limiting friction. And the second type of friction, which is known as the kinetic or dynamic friction, is defined as the force that must be overcome so that a body can move with a uniform speed over another body. So what does this mean? For example, let's say we have a drum rolling on a plane surface. So far that the drum is rolling, there will be a frictional force that is limiting the drum from attaining its full uniform speed. And this is known as the kinetic or dynamic friction. Now, let's look at the laws of friction. Let's say, for example, we have a rough surface. So this is known as the diagrammatic representation of a rough surface. And we have a block on the rough surface. So this is a block. So here we have our motion, which means the block is moving forward. And we say friction is a force that opposes motion. So there will be a friction, which is the F force. So this is known as the frictional force. So in this case, we will have the weight acting downward, which is the W. And we have our normal reaction, which is the R. So this R is known as the normal reaction. So in this block, if the block is moving forward, definitely we will have a motion of the block, but there will be another force, which is the frictional force acting as an opposition to the motion. And we have our weight acting downward, which is the weight of this block. And lastly, we have our normal reaction, which is the R in this case. So for this case, if we are having an horizontal plane, the normal reaction is always equal to the weight most times, so far that we are dealing with a horizontal plane or a plane surface. So for this case, we have something called the coefficient of friction, which is denoted as mole. So this is the symbol. So we have the formula to be equal to the frictional force over normal reaction, which is the R. So for this moon doesn't have any unit or any SI unit. So the formula for the coefficient of friction, which is known as moon, is given as the frictional force over normal reaction. So this is our frictional force. And this is our normal reaction. Remember I said when dealing with a plane surface or a horizontal plane, the normal reaction is mostly equal to the weight. And for this case, that is why we are having our coefficient of friction, which is known as the moon, to be equal to F over R, which is the frictional force divided by the normal reaction. And the coefficient of friction doesn't have any SI units. And the second law of friction, it says that friction is independent of the area of surface in contact, so far as the normal reaction is constant. So what this is telling us is that friction does not depend on the area of surface in contact. Because if the normal reaction is constant, there will always be a frictional force on the plane. So friction is independent of the surface area in contact. And that is all about the laws of friction. Let's look at some practical examples under the coefficient of friction. Our first examples as displayed on the screen says that if the coefficient of friction between two surfaces is 0.4 and the normal reaction is 50 Newton, what is the frictional force? So in this case, whenever we are given any question, the first thing to do is to write the given parameters. So for our question, we are given the coefficient of friction between the two surfaces, which is 0.4. So our moon, which is the coefficient of friction, is given as 0.4. Remember I said it doesn't have any units, so that is why we are just having 0.4 in this case. And secondly, we are given the normal reaction, which is the R, to be 50 Newton. And they asked us to calculate the frictional force. So from our formula, which is given as moon equals to the frictional force over normal reaction. So we are calculating the frictional force in this case. So we have our moon to be 0.4 and we have our frictional force, which is what we are looking for in this case. And we are given the normal reaction, which is the R, to be 50 Newton. So for this case, we can just cross multiply. And when we cross multiply, this will go here. We have our frictional force to be equal to the 50 Newton, which is 50 multiplied by the 0.4. And when we press this in our calculator, we have our frictional force to be 20 Newton. And this is our final answer to questions of this type. Let's look at another examples under the coefficient of friction. The examples as displayed on the screen says an object of mass 80 kg is pulled on an horizontal rough ground by a force of 500 Newton. Find the coefficient of static friction. So for this case, we have our mass, which is the m, to be equal to 80 kg, and we are given the force on the rough ground, which is known as the frictional force, to be equal to 500 Newton. And they are asking us to calculate the coefficient of static friction, which is the mole, to be equal to unknown. So for this case, we were not given the normal reaction. And remember I told you, I said the normal reaction is the same thing as the weight when dealing with a plane or an horizontal surface. So for this case, our weight, which is the W, is equal to mg. And in this case, we are given the mass. So we have our W, which is equal to the weight, to be equal to 80 multiplied by the gravity, which is 10. So in this case, our W will be equal to 800 Newton. And we say our W is the same thing as our R, which is the normal reaction. So our R for this case, the normal reaction will be equal to 800 Newton. And we can now use our formula of static friction, which is given as mole equals to the frictional force divided by the normal reaction. And we are given the frictional force, which is equal to 500 Newton divided by the 800, which is the normal reaction. And when you input this into the calculator, you have your mu, which is the coefficient of static friction, to be equal to 0.625, and it doesn't have any unit, so our answer will be equal to 0.6. So this is the final answer for questions of this type. Next up, we'll be looking at the angles of friction. So we have the angles of friction. So for this case, the relationship between the coefficient of friction and the angle of friction is given as the mole to be equal to the tan angle of the friction. So in this case, our moon is given as the tan theta. So under this, we can say our moon to be equal to sin theta over cos theta. So in this case, from the relationship of trigonometric identity, we have our sin theta over cos theta to be equal to tan theta. And this is a way we get our angle of friction, which is given as the coefficient of friction to be equal to the tan angle of the friction. So let's look at some practical examples under this concept. The examples as displayed on the screen says that a block just starts to slide when the incline is raised to 37 degrees. What is the coefficient of friction? So in this case, we are given the angle, which is equal to 37 degrees, and they are asking us for the coefficient of friction, which is our mole. So in this case, we have our formula, which is the coefficient of friction to be equal to the tan angle of the friction. So for this case, we can say our coefficient of friction, which is what we are looking for, to be equal to the tan angle of what we are given. So in this case, we are given 1037 degrees. And when we press this into our calculator, we have our coefficient of friction to be equal to 0.753. And this is our final answer to questions of this type. Next up, we'll be looking at the motion of an inclined plane. So we have the motion of an inclined plane. Under the motion of an inclined plane, let's say we have an inclined plane and we have a horizontal surface, which is the rough surface. So on this inclined plane, let's say we have a block. So as usual, this will be our motion, which is the m. And here, this will be our frictional force that is opposing the motion, which will be our F. And here we have our normal reaction, which is R. But for this case, remember I told you when we are having an horizontal surface, the normal reaction is always equal to the weight. But for this case, if we are having an inclined plane, the normal reaction is not equal to the weight. Because for this case, the weight will be acting parallel to the surface. So if the weight is acting parallel to the surface, we have our W to be the weight. So in this case, our R, which is the normal reaction, will be given as mg cos theta. And how do we come across this mg cos theta? This mg cos theta is given as our formula for the normal reaction, because when we have our weight to be equal to mg, our normal reaction, which is R, will be equal to mg. But how do we come across this cos theta? Remember from our trigonometry, we have this to be our hypotenuse. So this is your hypotenuse, which is HYP. And we have this to be our opposite. So this will be our opposite. And this will be our adjacent. So because this normal reaction is acting perpendicular to the surface, we have our reaction to be mg cos theta, because this will be our hypotenuse and this will be our adjacent. And remember from SOHCAHTOA, we have our cos theta to be equal to the adjacent, which is this adjacent over the hypotenuse, which is the hypotenuse of the normal reaction. And that is how we get our normal reaction to be equal to the mg cos theta. So for this case, our normal reaction, which is acting perpendicular to the surface, will be given as our hypotenuse divided by the adjacent. And that is how we come across our R equals to the mg cos theta. So for the weight, which is the W, we have our W to be equal to the mg sin theta. So you can see the weight and the normal reaction is not the same for an inclined plane, because if the normal reaction is acting perpendicular to the surface, the weight will be acting parallel to the surface, because this weight, the angle will be given in this case because it is acting parallel to the surface. So for this case, our weight, which is equal to mg sin theta, you can remember this will be our hypotenuse, this will be our opposite, and this will be our adjacent. So the weight angle will be given as the opposite over hypotenuse. And that is how we get our sin theta, because remember from SOHCAHTOA says the opposite over hypotenuse will give us sine, and we have the opposite here and the hypotenuse here with the angle that the weight is making with the inclined plane, and that is how we get our weight to be equal to the mg sin theta. So for this case, our weight and the normal reaction is not always the same for an inclined plane, but for a plane surface, the weight and the normal reaction is equal. But if the weight is also acting perpendicular to the surface, let's say we have the weight here. If the weight is also acting perpendicular to the surface, definitely our normal reaction and the weight will be equal to the same. So remember, if the weight is acting perpendicular as the normal reaction, our weight will be given as mg cos theta. But if the weight is acting parallel to the surface, our weight will be given as mg sin theta. And recall from our formula for the coefficient of static friction, we have our mole to be equal to the F over R. And in this case, we have the mole to be equal to the F over mg cos theta, which is the formula for the normal reaction in an inclined plane. So we can put our mg cos theta here. So in this case, when we cross multiply, we will have our frictional force to be equal to the coefficient of friction multiplied by the mg cos theta. So this is given as our formula for frictional force for an inclined plane. So let's look at some examples under this concept. But before we look at the examples, let's say the block is sliding down the plane. If the block is sliding down the plane, our net force, which will be equal to the F net, will be given as the W minus the frictional force. So in this case, our W is equal to the mg sin theta. So we have our F net to be equal to the mg sin theta minus what is our frictional force? So our frictional force is the coefficient of static friction multiplied by the mg cos theta. And this will be given as our F net if the block is sliding down the plane. So this is the formula for our net force if a block is sliding down an inclined plane. So let's look at some examples under this inclined plane. Example 1 as displayed on the screen. The question says a block of mass 2 kg rests on a smooth inclined plane making an angle of 30 degrees with the horizontal. The normal reaction on the block is. So for this case, we are given the mass which is equal to the m to be equal to 2 kg, which is the 2 kg. And we are given the angle which is theta to be equal to 30 degrees. So in this case, they are asking for the normal reaction of the block. So back to our formula, the normal reaction is given as R to be equal to the mg cos theta. So for this case, our normal reaction, which is R, will be equal to our mass, which is 2, multiplied by the g, which is gravity. So we can use g as 10 and multiply by the cos of 30. So in this case, our R will be given as 20 multiplied by 0.866. And in this case, our final answer will be given as R to be equal to 17.32 Newton. And until then, don't forget to give this video a thumbs up and don't forget to hit subscribe to Tech and EduSpark Hub so you won't miss any tech content or educational school lesson coming up your way. And until next time, keep learning, keep coding, and I will see you in the next one.